Welcome to the first video of the calculator section of this SAT test. Notice that the formula chart is exactly the same as the other test. However, you're now allowed to use a calculator. So every number, ideally every question on this test can be solved without a calculator. It's just that long division and multiplication gets a little bit difficult and tiresome after a while. So I recommend using a calculator. Pretty simple, pretty straightforward. I would try to include examples of how to solve this on a calculator for some of these questions, or how to not even use a calculator at all. So, that being said, let's go on to our first question. Let's look at number 1 now. John runs at different speeds as part of his training program. The graph below shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So we need strictly increasing and strictly decreasing. Okay, so looking at our graph here, how about this? Let's go to our answer choices. They're saying between 0 and 30 minutes, it's strictly increasing, and then strictly decreasing. Is that true? Here is 0 to 30. I'll mark it off here, 0 to 30. Is that true? Looks like it increases, then it just stays steady. That's false. So it looks like it's not A. What about B? Between 40 and 60, so 40 and 60. That looks like it's strictly increasing and strictly decreasing. Our graph goes up, then down. So that's a possible answer choice. What about C? Between 50 and 65. So here's 50 and then 65. I'm going to try to draw it there in the middle. Well, looks like that's a decrease and an increase. So that actually won't help us. It's the opposite direction. It's not C. And then what about D? Just for fun. Between the intervals 70 minutes to 90 minutes. Yikes! That's not it. Let's say steady, then a pause and a jump to increase, and then 90 minutes should stop right here. Regardless, though, looks like it won't be D. Looks like the answer choice would be B, between 40 and 60 minutes. Okay, let's look at number 2 on this test. If y equals k times x, where k is a constant, and y equals 24, when x equals 6, what is the value of y when x equals 5? So they give us this nice little equation here. Y equals kx. That is terrible. Let me rewrite that real quick. Perfect. They give us this equation, y equals kx. The last question is saying, what is the value of y when x equals 5? So ideally, if we knew what the value of k was, we could just plug in that value of k, multiply by 5, and then we get our answer choice. But we don't know what k is just yet. But what else do they give us? They say, hey, you can find k actually, because when y equals 24, it just so happens to be that x equals 6. So they love these type of questions on the SAT, where it's really a two-parter. It seems like they didn't give you enough information, but they actually did. And once you find this unknown value, you just go back to your original equation just to plug it in. So let's solve for k here. I'm going to divide both sides by 6. That's a 6, not a g. K in this case would equal 4. And now we plug in to this equation again, y equals kx, where in this case k equals 4 and x equals 5, which would give us an answer choice of 20, which would be answer choice C. Okay, let's look at number 3 now. In the figure above, lines L and M are parallel and lines S and T are parallel. If the measure of angle 1 is 35 degrees, what is the measure of angle 2? Before we answer this question, let's go back to some of the definitions of parallel lines and transversals. So I've attached here some of the definitions that you may have remembered or you may have forgotten about from geometry class. So on the left here we have vertical angles, then we have corresponding, alternate exterior, and alternate interior. So this only applies when we have two parallel lines and a line that crosses both of them. That line that crosses both of them here, that's called a transversal. So for vertical angles, vertical cross. So 1 and 4 are congruent, or they're the same. 2 and 3 congruent. 5 and 8, and 6 and 7. This is how it looks like for vertical angles. For corresponding, it's pretty similar actually. So notice that both of these angles are on this transversal, and it's just each of them corresponds to each parallel line. So same thing here. And then for alternate exterior, notice again, it's on this transversal, but it's just on the outside of this parallel line and outside of this line. Same thing on this transversal, on the outside of this line. And then finally, alternate interior on this transversal, but it's on the inside of these parallel lines. On the inside of these parallel lines. As we look back at this question number 3, all they give us is that measure angle 1 is 35 degrees, and they somehow want us to figure out what is measure angle 2. Well, what do we know? We know that using this, we can say with our corresponding angles, this measure angle 1, we have a corresponding angle here. And then from here, we can also see, and this is kind of hard to see, you kind of have to tilt your paper to the side, but this side right here is also a corresponding angle. Now, another way you could have said it is, let me get a different color. Oh, okay, we could have said this angle here and this angle would be congruent, and likewise this angle and this angle would be congruent. Now, we can't really go much farther from here. If we want, we can say this is a vertical angle, but that one won't really help us too much. But here's what we know. We know, since, let me get black out, this one was 35 degrees. That says this angle here is 35 degrees. It also says this angle here is 35 degrees. That's what it means if it's congruent. It is the same measure. Same thing here. This angle will be 35 degrees, and this angle will be 35 degrees. Well, what do we know about a straight line? We know a straight line has 180 degrees. So while I may not know right now what is measure angle 2, I do know that measure angle 2 plus whatever this measure angle is going to equal 180 degrees. Well, we do know what this measure angle is. That would be 35. Let me just do it like that. So measure angle 2 plus 35 degrees equals 180. And just to solve for measure angle 2, subtract 35 from both sides, and we'll get measure angle 2 equals 145, giving us an answer choice of D. Let's look at number 4 now on this test. If 16 plus 4x equals 10 more than 14, what is the value of 8x? So what they want you to do here is to put this into equation. 16 plus 4x is 10 more than 14. Solve for x in that equation, and then plug in the number for x into 8x. So let's change this expression here into an equation. So we have, if 16 plus 4x, if that is usually means equals, so 16 plus 4x, if that is equal to 10 more than 14, so more than would be addition, so 10 more than 14. If that's the case, well, first we need to figure out what is x. So let me just rewrite my right hand side. 10 plus 14 is 24, and then we just solve for x. Subtract 16 from both sides. Divide by 4, and x will be equal to 2. So if 16 plus 4x is 10 more than 14, what is the value of 8x? Well, we know that x is 2, so 8x would equal 8 times 2, which would give us 16, or an answer choice of C. Which of the following graphs best shows a strong negative association between D and T? So let's say we have 4 scatter plots here. Answer choice A, B, C, and D. So notice that this question gives us 2 parts. A strong negative association. So normally positives going in that direction, negatives going in that direction. So what does it mean strong? What does it mean negative? Well, let's look at our answer choices. A, all of our dots are going down in this negative direction. If you want, you could think of it as a negative slope direction. So all of our dots are going down in this negative direction. But look at the dots. Are they close together? Are they far apart? They're actually pretty not compact as compared to these other ones. This right here would be a weak and a negative association. It's weak because all the points are kind of scattered a little bit, but it's negative because they're all going in one direction, and that direction is in a negative direction. Okay, what about this next one? It's kind of strong somewhat. However, they're not really going in a direction. They're kind of going to the right. I would actually say this is probably a no correlation. This might have a small positive correlation, but it's very small, very small. So I would just say this was a no correlation. That's a bad spelling, but it says no correlation. Okay, what about C? Let's look at the points. They're pretty bunched up. They're pretty close together. So I would say that's strong. What about it? Are they going in the positive direction or negative direction? It looks like it's going in the positive direction. It looks like it has a positive slope. So it's a strong positive correlation. Finally, again, answer choice D. It's pretty strong. They're all pretty bunched together, so that's strong. And what direction is it going? Negative, positive. Looks like it has a negative slope, so I would say weak. I would say negative, not weak. And we wanted to figure out which answer choice has a strong negative association, so that would be D. So just to recap, if it's all far away, it looks like that's a weak correlation. If they're bunched up together, they're pretty close knit, that would be a strong correlation. And in order to determine negative and positive, think of it as slope. If this was a negative slope, this would be going down in this direction. If this was a positive slope, it would be going down in that direction. Okay, let's look at number 6 now on this test. A hospital stores one type of medicine in 2 decagram containers. Based on the information given in a box above, how many 1 milligram doses are there in one 2 decagram container? So this is a form of, you may have heard it called dimensional analysis in your chemistry class. Regardless, it's a way to change from one unit to another unit. So in the end, we want to end up with milligrams, but we're starting off with decagrams. Thankfully, they give us the conversion here. 1 decagram is 10 grams, and 1,000 milligrams is 1 gram. So again, we're starting off with decagrams, and we want to end up with milligrams. So I'll write this here, 2, and I'll just do deca. So again, you may have learned it as dimensional analysis. One way we do this is we want to quote unquote cancel our units. So we want to have 1 unit on top and 1 unit on bottom. So in order to cancel out decas, I'll need to have deca here on bottom as well. Well, let's look at what we have. Well, what do we know? We know that 1 decagram is 10 grams. So 1 decagram is 10 grams. And so let's evaluate. Right now, we can, let me change colors here. We can cancel out our decagrams and get solely grams. And then our final answer will be in grams. Is that what we want? And it is not what we want. We want our final answer in milligrams. So let's keep going. What do we know about grams? Well, we know that there is 1 gram for every 1,000 milligrams. So if we were to right now cancel out our units, so 1 on top, 1 on bottom, 1 on top, 1 on bottom, and we're to multiply all this out, we will end up having milligrams in the very end, which is what we want. So now the question is, how many? Again, as you may have learned in dimensional analysis, what you do is you multiply all your top numbers together, and then you divide by every number on bottom. So we'll do 2 times 10 times 1,000, and we divide all that by our numbers on bottom, which in this case is actually just 1 times 1. So that isn't too bad. We'll end up getting an answer choice of D, 20,000.